I wanted to talk to you about a personal project of mine that I've been working on for 2 or 3 months. It's called Binary Repository and node streams, which is what I implemented it in. I wanted to back up my data. I wanted to store them in a, backup as in backup. I wanted to store my backups in a remote location. They should be readable only by me. I thought this was, quite important because if they're going to be in a remote location, only I should be able to access them. Lots of things get leaked nowadays and hacked, so if I can keep it under control, then I'll be happy. I'm also a Linux loving hippie, so Linux support is a must. And open source as well, because there's no point in trusting your data to a commercial company for them to go bust to be able to not get your data. Resource usage should be limited and sensible. I cobbled together a solution before and it had really high CPU usage, not one that I programmed. So I wanted to keep that under control. And also I wanted versioning in there. So if I put rubbish data over good data, it wouldn't immediately lose my good data to replace by rubbish data, or if I found out much later on that I'd replaced my good data, then I wanted to get back. This was one of my inspirations, but with Git, you can put anything in there, it's really good. But if you was to put in like an MP3 file and it was 10 meg, it wouldn't be happy. If you was to put in a movie file and it was a gig, it would really not be happy. Also, it doesn't encrypt things, which is a bit of a problem. So those two requirements that I had were failing to be met. I put together a process of the design, basically. I knew that if I looked at all the files and checked the modification times and the sizes of all those files, I could make a good approximation of what I needed to back up. This is how rsync works, if you're familiar with that. Once I have a list of things I need to back up, I can do an SHA-256 checksum on those files to create an ID, or part of an ID. I can then break those big files, which are potentially a gig or so, into multiple parts. I can then encrypt them using good old bash and GPG. So at the moment it probably works on Macs. I don't have a Mac, as seen earlier in my pointing and clicking lack of practice. It's tested well on Linux. I don't believe it will work on Windows, but who uses that? After that, you can upload them all to S3 or local, those two are implemented, or anywhere else. It's all quite modular. It only backs up the data at that point. So you're collecting all these parts of files which are identified by part number in SHA-256sum. There's no file names, which would be a bit of a problem if you wanted to bring back your data. There's no, there's none of the other things which you need to be able to check again, which is modification time and size. But the next stage is it collects a load of data, as much as it can, like 64 meg I think is what I set it to, for a part, and 256 meg for a commit. Once it's got a commit, it will then upload all the metadata, again encrypting it, and uploading it to S3, local, or wherever. What does it look like if you run it? So this is a terminal session. How do I zoom it in? Do I? Command, Shift, plus? That's good enough for now. So it's a terminal app because it runs anywhere. So if you had if you wanted to use it, the first thing you need is an S3 bucket. So go off and create one. Then start tmux, because everything runs under tmux in my world. As a first user, you would create a directory to put your data. And then you would initialize it. You would then copy a load of data into that directory. And then you can look at what you're about to upload, which is a Blade Runner soundtrack. You would then upload all that data. So this is going up. Every file in there is getting checked against a list of files which are not there at the moment. It's getting SHA summed and then uploaded into S3. At this point, it's not uploading the metadata, the file names and things like that. It's just uploading chunks of data. If you look at the data directory, you can see there's a whole bunch of things identified by SHA sums and part numbers. And if you was to want to get your data without having to trust anybody else, including me, you can look at a commit file, find the SHA sum, find out what object inside the bucket you want to download, pipe it into GPG, and there's your data, which in this case is a track listing. If you do push, all the metadata will be uploaded. Along comes, then you can see the commit file has been added to the S3 bucket as well. Along comes another user. He can also create a directory and initialize it pointing at the same S3 bucket. There we are. And then he will do a fetch, which will get the commit file itself. Well, at the moment he's downloaded the commit file and is now currently downloading all the chunks of the data itself. It is actually downloading the data itself now. Once it's got all the little bits of encrypted data, it will then go off and decrypt the whole lot for the one commit. It downloads per commit and then decrypts. We're going to change that file because the directory listing, which was the track listing, is a bit ugly. So we're going to make the changes we need to make. We're going to then save it. And then we're going to push that change back up. So that's the change going up of the data itself. Then you're going to push the commit back up. The first user comes along. And then does a fetch to get the changed commit file. Sees that the track listing has been modified and then downloads the track listing. If we then look at that track listing, we will see we have the data that the other user changed. So that's the quick demo. Now I have to figure out how to get back to the browser. Anybody know how to get out full screen on a Mac? Escape? Doesn't work.
Put your mouse right to the top and there might be
Aha, thank you. Ooh. So how does that all work? So the whole process is a stream, and it's a node stream to be more specific. In node streams you have a readable, you then have 0 or more transform or duplex steps, and you have a writable at the end. The code that you do to do that process just looks like this pretty much. So this is on the outside looking in. You have create an instance of your reader, which would generally be a subclass of streams.readable. You then create a subclass of transform or potentially duplex. And then you create a subclass of writable, and you just do .pipe. And it flows from the reader to the writer with not having to mess around with any messy code to manage that flow. It just automatically works for you. But you have to program it in the style which it says. So first thing you need to do is create a reader. Ooh. Spacebar works better. This is what the reader might look like. It's probably about the most basic implementation you can do. So in this situation, all I'm doing is I'm subclassing streams.readable. The only thing you have to do, there are other things you can do, but you really have to implement the underscore read method, which receives a size which you can just blindly ignore if you wish. But it's a recommended size which the system is requesting to read. If you ignore it and just put the whole data in, your memory usage will go up, but it might still all work if you don't put too much in there. In any case, you need to call the push method with data that you want to push into the stream. And when you're done, you call the push method with null. That's it, nothing more. This is what a transform method looks like, or transform class, sorry. Again, you only have to really implement one thing, the underscore transform method. It has 3 parameters, chunk, encoding, and callback. Chunk is the data that you want to process. Encoding tells you the encoding of the data if it's not an object. So the streams framework in Node is all for reading files and reading HTTP. So if you can do a lot of really low-level stuff with this, but if you're doing object mode, which is what I'm doing here most of the time, you can just ignore encoding, and there's a callback too. All you do is you take the chunk, you transform it, and then call the callback after you've finished. Sorry, you call push in the middle. You don't have to call push once, you don't have to call push at all. You can call push multiple times. If you think about it, you might be taking compressed data and returning or feeding through uncompressed data. So you're going to have a header. You might not be calling push at all for a while. And then once you've got the data, you're going to be calling push many times for every bit or byte you actually import. So there's no requirement to have the same amount of pushes as transform steps. Last of all, you have a writable. The writable, like transform, has chunk encoding callback. But there's no push because there's nowhere else to push it, so you just call the callback when you're done dealing with the chunk that you were fed. What I haven't covered is duplex, because duplex is more complicated, but duplex is only a combination of read and write in one. Basically, you write to the source side and you read from the destination side. So transform is really a simple version of duplex, but not as powerful. Very easy mistakes to make in streams because it's quite low level. Doesn't seem obvious when things break. If you have a transform, you must always call the callback. If you don't call the callback, the whole thing just stops. Similarly, if you don't attach a write, it will keep flowing for a bit and then it will stop because it will notice that it's not actually, the data that you're sending through isn't going anywhere. Also, and this is one that got me because it's pretty much undocumented in the API, and GitHub will give you the answer eventually, but the API hints, because you just have pipe methods, that you might be able to take 2 things and pipe them into 1, or take 1 thing and pipe it into 2. You can't do that because it's waiting for nulls at the end of the stream, and if you do that, you end up just with 1 null going to one place and no null going to the other place, and it's all mess. The way to implement that is to use duplexes and create more classes with, so you have basically a writable on one side and then you might have 2 readables on the other side of one object. It's a bit fiddly and it's not so beautiful, but it does work. It's often best to make yourself an equivalent of map filter reduce in there. I created a little set of functions called stream dash that has those map filter reduce functions in them. I'm not advocating people use it, but I did put it there as a reusable piece of code for me to use. There are things like this just for Vanilla.js, but I was using TypeScript, so I had to kind of make my own or write definition files, which is more trouble than writing your own quite often. This is the project that I was implementing. It's called Binary Repository and it's on GitHub. It's open source. Could do with some Mac testers because I clearly don't know what I'm doing with a Mac. It does work on Linux. Everything is implemented in JavaScript except GPG, which is probably not viable to implement in JavaScript and requires shelling out to the shell. Thank you for listening.